Hey, what's going on, guys? We're going to go ahead and start our conic section unit right now. Conic sections are basically what they sound like. They're slices of cones, okay? And they will end up being either circles, ellipses, parabolas, or hyperbolas, okay? And you'll kind of understand a little better as we go. But the easiest one to go through first, we're just going to do an overview of every single one, as throughout the week. The easiest one is probably the circle to understand. So this is going to be conic sections, this whole unit here. We're going to spend all week on it and most of next week. All right, conic sections. So there's a general form for all conic sections. We're going to write about that first, general form. And this is what it's going to be. It's going to be ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. That looks pretty daunting, right? But it's actually not that bad. It just depending on what these coefficients are, you'll get a different conic section by changing these around. Making some negative, making some 0, you'll end up getting different conic sections. But right now we're just going to talk about circles. So I'm going to tell you this: if A equals C, the conic section is a circle. So we'll just talk about all the things I want you to know about circles today. So if this coefficient of x squared is equal to the coefficient of y squared, then you're looking at a circle. And that's how you can tell. I can give you some random equation like this, but if you notice that this coefficient and this coefficient are the same value, right? And that's all it is, then you know it's a circle. Okay, so let's talk about kind of where circles come from, or at least from the context of what we've already seen. So if you recall the unit circle, when we had this right triangle, we had this angle here, and then I called this, let's change this color, I called this x, and I called this y, and I called this r, your radius. If you use the Pythagorean theorem, you'll get x squared plus y squared equals r squared. Okay, and basically that's the equation of a circle, of this particular circle. You'll get a circle that goes around like this. Oh, look at that perfect circle. All right, and that center right there is the origin. So this is a circle centered at the origin. Oop, I didn't mean to do that. Centered at the origin. Okay, so a standard form. So we have a general form, and there's going to be what I call a standard form for a circle. Will look like this. It'll be x minus h squared plus y minus k squared, and this will equal the radius of the circle squared. Okay, that's your standard form, and the center will be at the coordinate h comma k. So when I say this, the center is at h and k. So if your center were at the origin, which is 0, 0, h and k would be 0, and then you would end up with this. So basically this right here is a circle centered at the origin, which is what the unit circle is. So that's where that comes from, that part of it right there. Okay, so let's do an example of kind of sort of questions you could get with circles. There's not really too many complex questions with circles because they're very straightforward, but the other conic sections are significantly more complicated, more sophisticated stuff you're looking at. So let's take a look at this. So if I say, let's do an example question. What is the standard form equation for a circle with center -3, 4 and radius 6? Okay, so I'm going to write an equation for a situation like this where you have a center at the coordinate -3, 4 and a radius of 6. So this is really straightforward because this is h and this is k. Oops, so I hate it when I hit that little button on my, there we go. See if we can get rid of that. There you go. Okay, so this is h and this is k. So what we're going to do is we're going to say x minus -3. So this is -3 is this h. So if I say x minus -3, it'll be +3. when you subtract a negative, you add. So we'll get this, and then I have y minus 4. That's going to be my k. And this will equal r squared, which is 6 squared. The radius is 6, so this is going to be 36. And that's all that you would have. That's all there is to it. This is your standard form equation for a circle that fits this situation here, okay? So what I'm going to do now is show you how to write this in the general form. So this is the standard form. If you recall, the general form I wrote up here is this guy. So how are we going to convert from standard form to general form? Well, I will show you how this can be done, okay? So what we're going to do really is we're just going to FOIL this and FOIL this, okay? So this is going to end up being x plus 3 all squared. Actually, let's write it like this. Keep changing my mind as I start writing things, okay? I write it as x plus 3 times itself. And then plus y minus 4. There's a delay here on the screen. Times itself equals 36. So we're going to just FOIL this out. So this is going to give me x squared plus 6x plus 9. And this will give me y squared minus 8y plus 16. And we'll just group these like this, okay? And this will still equal 36. Still equal 36. Okay. Now, let's scroll down. We'll extend this page a little bit. Okay. So I'm going to combine the like terms here, or combine any terms. I have x squared and y squared. I'll write those first. I got plus 6x minus 8y. I got 9 and 16, which make 25. And this will still equal 36. So I just need to get this to equal 0, so I'll subtract 36 from both sides. And this is what I'll end up with. X squared plus y squared plus 6x minus 8y minus 11 equals 0. This would be what I would call my general form for this equation, okay? So this is the general form. So if I give you an equation like this on a test, if I were to, for instance, I would say, okay, what kind of conic section is this just by looking at it? You can see that the coefficient of x squared and y squared are both 1. So basically, it's a circle right off the bat because a is equal to c right here. So this is kind of what I'm talking about. So we went from standard form to general form, and now how do we go back from general form to standard form? That's kind of the other thing you have to know how to do. And that's actually, this part's really important here actually. So how do we go, let's turn this page here. How do we go back? Okay, so to go backwards, we will complete a square. Okay, so we're going to look at our x terms. We're going to write those first. We're just going to go backwards. And before I move on to the y's, I'm going to put a blank right here because I'm about to complete a square. So I'm done with the x's. Let's go to the y's. I got y squared minus 8y. And then I'll put a blank after that. I am going to take this negative 11 and move it back to the other side, so this will be positive 11. And then since I have 2 empty blanks on the left, I'll need 2 empty blanks on the right. And we're going to fill up all these blanks. So here's how we're going to do this. I'm going to take half of this middle coefficient right here. So what is half of 6? That's going to be 3. And I'll square it. So 3 squared is 9. So I put 9 on, I'm adding 9 to the left side, so I'll add 9 to the right side as well. We'll do the same thing here. Half of negative 8, which is negative 4, we'll square that. This will give me 16, and I will add 16 to both sides. So what I'm now looking at here is a completed square right here. And this is going to be x half of 6 right here, which is 3 all squared. And then here, we've done completing squares in algebra. You should have done them in algebra 2. And we have y half of negative 8, which is negative 4 all squared. And then, so what I'm saying when I say this is if I square this, I'll get that. Obviously, we're just going backwards. 11 plus 9 and plus 16 is 36. So what you see here is that I went all the way right back to my standard form. So I converted back to my standard form, which was this form right here. So that's really all there is to really know. Honestly, for circles is where the center is, where the radius, how the radius works right here on the end, and of course how to draw them. So if you know where the center is and you know the radius, that shouldn't be very difficult to draw. You're just going, away from the center in every direction the distance of the radius, and then you just make a circle. So we will kind of work on those things, but circles are pretty straightforward. The other ones are a little significantly more complicated, and you'll see some things that you've probably never seen before, like a directrix or foci or eccentricity. All these are elements of the of conic sections. So that'll get a little more sophisticated, but this is where we're going to start off with. Your first homework will be over circles only. So that's the overview, and I'm going to do some example problems in my next video, which I'll post up here just a little bit here on today, and then we'll just go from there. I appreciate you watching.